Our solar system has a lot of moons. Like a lot of moons. According to the Astronomical Union, there are 416 planetary moons. NASA's JPL lists a further 507 small body satellites that are orbiting the same planets. So, maybe like some Idaho potato moons. From this almost 1,000 moons, there are some rather interesting ones. From the icy worlds of Europa and Enceladus to the fiery lava world of Io, there are just a lot of intriguing ones out there. However, there is one moon in particular that really stands out. I would go so far as to say that one could even mistake it for a planet. It orbits one of our solar system's gas giants, Saturn, and it could be hiding much more than we might originally expect. This is Titan. And it is way cooler than I thought when first going into this. Titan is the second largest moon in our solar system. It is sometimes referred to as a planet-like moon. To give a comparison, it is physically larger than Mercury, but it's not as massive. It only has about 40% of Mercury's mass. Comparing it to our moon, though, Titan is a behemoth. Its diameter is 50% larger, and it is 80% more massive. In fact, there is only one moon in our solar system that can truly enter the ring and duke it out with Titan. And that is Jupiter's moon Ganymede, which also happens to hold the title of the largest moon in our solar system. Titan was discovered by Dutch astronomer Christian Huygens. He was fascinated with Galileo Galilei and the work that he had done to advance telescope technology, along with his discovery of Jupiter's 4 largest moons in 1610. Working with his elder brother, Christian set out to build telescopes of his own starting in 1650. Only 5 years later, on March 25th, 1655, he would go on to discover Titan using one of the telescopes that he had built. He named it Saturni Luna, which stands for Moon of Saturn. And it would remain like this until 1847, when it was given its current name Titan by astronomer John Herschel. Now, when looking at Titan, you might notice something rather unusual for a moon. It has this thick, golden, hazy atmosphere, which actually really does make it look like a planet. And this is part of what makes Titan so unique, as it is the only moon in our solar system that has such a dense atmosphere. The atmosphere of Titan is so dense that it exceeds even ours here on Earth. When compared, we find that the atmospheric pressure at the surface of Titan is 60% greater than here on Earth. Here we have the deepest swimming pool in the world, and it has a maximum depth of 200 feet. Now let's say we go for a dive into this pool. Once we reach a depth of about 50 meters, the pressure we feel would be similar to the pressure we would feel on the surface of Titan. Its atmosphere has clouds and is comprised mostly of nitrogen, methane, and hydrogen. The composition does not always look the same, though, and it changes depending on where in the atmosphere you are measuring. Nitrogen, the most abundant of them, has its highest concentrations in the upper atmosphere, but it steadily decreases as we get closer to the surface. The overall methane concentration is lower in general, but it increases as we get closer to the surface. This is because Titan has a methane cycle that is not unlike our water cycle here on Earth. This allows methane in Titan's lower atmosphere to cycle between a gas and a liquid. It is also interesting in general that this methane is still there. In just a short 50 million years, short for the solar system anyway, the sun should have converted all of Titan's methane into more complex hydrocarbons. This most likely means that the methane is coming from somewhere. It's being replenished. One thought on this is that its source may be from Titan's interior, ejected from cryovolcanoes that are found on its surface. Let's talk more about the surface of Titan, as it is complex, geologically young, fluid processing, and overall just quite unique in general. Now, while Titan itself is the age of the solar system, so around 4.6 billion years old, its surface seems to be much younger, coming in closer to the range of 100 million to 1 billion years old. This suggests that its surface is being renewed in some way, such as by some geological processes. Now, a challenge with studying Titan's surface is that its thick atmosphere pretty much blocks any form of visual light astronomy. To get around this, spacecraft like Cassini, Voyager, even the Hubble Space Telescope have used infrared instruments, radio instruments, and radar to take measurements of Titan's surface. This has revealed some interesting features of it to us. We can see in this image that the moon's surface has regions of both light and dark terrain. I would like to draw attention first to this area here, which is known as Xanadu, or at the very least, that is how I'm going to say it. This highly reflective area is about the size of Australia. Alrighty, man, I'm here. Every time you tell me that you have an idea, it is a disaster. So let's get this over with. Alright, man, thank you for giving me your time here. I promise you that this is not going to be a waste of it. It's very important. So, have you ever heard the conspiracy that Australia doesn't exist? No, I have definitely never heard that one before. Oh, really? You haven't? Well, yeah, there's a lot of people out there who just don't think that it's real, right? And I was going over this video earlier, and I saw that on Titan, there's a section called Xanadu that is about the same size as Australia. So, here's my guess, my hypothesis, if you will. I think that Australia is really on Titan. Wait, hold on. So you're telling me that you think Australia's on Titan. And that's why nobody thinks that it's real. Xanadu is a plateau-like region comprised of highly reflective water ice. Now, earlier, we talked about the pressure on Titan's surface, which is mostly due to its atmosphere. But now let's touch on the temperature found on its surface, which is around negative 179.2 degrees Celsius, which is negative 290.56 degrees Fahrenheit. Real cold. And so under these conditions, water ice behaves closer to rock than what we're used to ice behaving. So you could see it as like the mountains, or the hills, I guess, of Titan. But this has also allowed other formations to occur on Xanadu, such as dunes, hills, like I mentioned earlier, rivers and valleys, all of which were likely carved into the water ice by liquid ethane or methane. To the upper left of Xanadu, we can see a darker feature, and these are called maria. The Maria may have once been liquid seas of hydrocarbons, but now they are thought to be mostly plains, or entirely plains, so they have since dried up. However, this does not mean that Titan does not have any liquids on its surface. When we move towards the poles, the temperature starts to drop and it gets cold enough that liquid hydrocarbons can exist near indefinitely. And so we're going to get more lakes and oceans near the poles. If we look more into this, let's start at the North Pole, we can see Titan's three largest seas: Kraken Mare, Ligia Mare, and Punga Mare. These three together cover around 267,000 square miles. And their levels are similar too, so there's a chance that they're all connected hydraulically in some way. There are smaller lakes as well, probably caused by rainfall, though these may be seasonal. It is even possible that they can form closer to the equator of Titan, but this would probably be during times of heavy rainfall. The oceans and lakes found on Titan are mostly made out of liquid methane, but there's also smaller amounts of ethane mixed into there and some dissolved nitrogen as well. So far, we have covered Titan's atmosphere and its surface, but what might we find if we were to descend even further, perhaps below its surface? And while we don't know for certain what is there, we do have some models on it based on data that we gained from the Cassini mission. And one of them suggests that the moon has 5 primary layers. Starting from the innermost section, which is a rocky core, roughly 2,500 miles in diameter, and surrounding this rocky core is a shell of water ice. This is a unique type of ice called ice-VI, which I only learned about during this video, and apparently it can only exist at extremely high pressures, so I suppose it would make sense to find this variant near the core of a planet or a moon. Now, above this layer sits a subsurface ocean of salty liquid water. Honestly, perhaps not unlike what can be found or possibly be found on Europa and on Enceladus. Then, above this surface is what we went over earlier, the outer crust of water ice. And that's where a lot of the lakes and the topological formations have come to be. Yet another way, that Titan is unique is that it also holds the possibility of supporting life as we know it, but even life unlike anything we have ever seen. Now, this, of course, does not mean that life is there. We certainly can't say anything pointing towards that. But it is still interesting. Like Europa or Enceladus, because Titan has that salty water ocean we mentioned earlier under its crust, which is maybe being kept that way by heat energy from the core, this gives us a chance at similar conditions for microbial life to form. And I would say that Titan's ocean has even more protection than some of the other moons, because above it is the thick water ice layer, but then above that is Titan's atmosphere, which is going to be blocking a lot of radiation that might be coming into that ocean. So there's definitely a chance that microbial life could form there. Beyond that, though, that very same atmosphere itself is rich in complex chemistry. Because the surface also has a liquid methane/ethane cycle with lakes and seas, it really is possible that new kinds of life forms that we just aren't familiar with might be capable of living there. To me, really, this just makes Titan like one of the most interesting potential targets for us to continue studying. In my opinion, there are at least a handful of moons in our solar system that, if possible, are worthy of dedicated missions. The already launched Europa Clipper being one such example of this. And if you would like to learn more about that, maybe check out this video somewhere up here. But it's looking like Titan might very well be getting a mission of its own. It's called Dragonfly, and it is scheduled to launch in July of 2028 and would be arriving at Titan by the mid-2030s. It will have a large drone powered by an RTG that is capable of flying through Titan's atmosphere. What its instruments will be studying is how far prebiotic chemistry may have progressed in Titan's atmosphere. In other words, it will be looking for how far Titan may be in the natural processes by which life can arise from things like simple organic compounds. Like so many other targets in our solar system, I am really excited to see what might come from studying Titan more. And let me say, if I'm still around here, like YouTube, when Dragonfly reaches Titan, or if we learn more about Titan from other sources and missions, you best believe I'll be right back here to talk about it more. And so with that, I hope that you've learned something and also enjoyed the video. If you have, please give me a like and subscribe and leave a comment. It's really appreciated. I always love hearing from everyone who does. And with that, let us all step outside tonight and look towards the stars.